On to part B. And this is actually a good example to follow up with after the previous one, right? Our previous example was extremely challenging. This one, we'll see that they're not all going to be crazy difficult like that one. So again, the goal is to really pick a side, use trig identities in algebra to try and end up with the other side. Okay? Our goal is to show that these two things are equal. Okay? So one good place to start is any side you want to pick. Okay? As I mentioned, I prefer to pick the more complicated side because I'm used to simplifying. Simplifying things seems easier to me than trying to make some expression more complicated. Okay? And is what we'd like is some string of equal signs, again, until we get to 1. Okay? That's what we want to happen. So a good place to start might be rewriting these things in terms of sine and cosine. So is what I mean by these things is cotangent of x and secant of x. These are all written in terms of sine and cosine. Maybe we can get a few things to cancel out. So cotangent of x is equal to cosine of x over sine of x. Secant of x is equal to 1 over cosine of x. And we still have this sine of x over here. And you might already see what's going to happen here. Maybe you don't. And if you don't, that's okay, because we can include another step in here before we write that this is all equal to 1. So what we could do is we could multiply all this together. That might be what your intuition was. Okay. So cosine of x times sine of x all over sine of x times cosine of x. And now you could probably tell me, well, this is equal to 1, right? Because you end up with cosine of x over cosine of x, which is equal to 1, and sine of x over sine of x, which is equal to 1. Okay. So this is all 1. Let's start part C by writing down the more complicated side, which is cosecant of x minus cosecant of x cosine squared of x. The first thing that I'm noticing here is that we have two terms and they both contain a cosecant of x. That means that we can factor out a cosecant of x, and that's going to leave us with a 1 minus cosine squared of x. Okay. Next, we might be feeling maybe a little stuck here, but strategy that's never a bad one to try is take this cosecant of x and try and write it in terms of sine. So cosecant of x is 1 over sine of x. And then we have this times this 1 minus cosine squared of x. And again, right now, this may not look like it's going to turn into sine of x, but let's just keep going. There's only one way to find out whether this will be what we need to get to sine of x, and that's to try it. Now, probably the hardest part of this problem is recognizing this here. I want you to look at that 1 minus cosine squared of x. Just try to think for a second. Where have you seen that? Or where have you seen something similar? And I'm going to start to write the answer here. In fact, we have 3 Pythagorean identities, but one of them contains pieces that look like that. Okay. So we have sine squared of x plus cosine squared of x is equal to 1. And if we want it to look like what's in the numerator of the expression that we have, well, let's just subtract each side by cosine squared of x. So we have sine squared of x is equal to 1 minus cosine squared of x. Okay. So this means that we'll be able to rewrite that 1 minus cosine squared of x as sine squared of x. Which will simplify to just sine of x. Okay. So we have went from the left-hand side of the equation to the right-hand side of the equation using just algebra and trig identities. Okay. And it is what we've done here is we've verified that these two expressions are equal for all x. Now that you can kind of see this, that we can have something complicated equal to something simple, you can maybe see why this is going to be a little bit useful. Okay. Well, if our equation starts off looking like this, or our function, whatever it is that we're doing, well, if it's just equal to sine of x, well, let's use this simple version. It's going to be a lot easier to work with. All right, part D. And actually, I'd say for parts D and E, I think they're worth giving a try now. Now that you've seen a few of these, pause the video, and at least give these an attempt. Okay, if you get stuck, that's okay. All right, so if I use the same general strategy, pick the more complicated looking side. That's what we have. Okay. And this one actually reminds me a lot of the first one, the second one we did, part B. Right? It just looks like it's a product of a bunch of sines and cosines if we rewrite things a little bit. And so this one really will be here too. If we were to take that secant of theta and rewrite it as 1 over cosine theta, and maybe you want to rewrite cotangent of theta right now, but you don't have to. I could leave this as cotangent of theta for a minute. And as what I see is in the numerator, the cosine thetas are going to cancel. So this gives us 1 over cotangent of theta. And then you might remember from your reciprocal identities that this 1 over cotangent of theta is equal to tangent of theta. On to part E. And what side do we want to start with? I'm gonna pick the right hand side this time. I don't think that there's a wrong side to pick here on this one. But let's see here. So secant of theta minus tangent of theta. Right now, this does not look like a quotient. Okay, there's no division bar in here anywhere. Okay. Well, let's make it so that there is. We know that we can rewrite both of these as quotients. So secant of theta is 1 over cosine theta. And tangent of theta is sine of theta over cosine of theta. And now note, these have the same denominator. Since they have the same denominator, we can just subtract them. So we have 1 minus sine of theta all over cosine of theta. And we're done. Okay. We started with the right-hand side, and we've ended up with the left-hand side. If any of you are curious how we could have done this starting with the other side, let's see what that would look like. So had we started off with 1 minus sine of theta over cosine of theta, one little trick is you can split the numerator here. I could rewrite this as 1 over cosine theta minus sine theta over cosine theta. And note, these two things are equal, right? And 1 over cosine theta is equal to secant of theta. And sine theta over cosine theta is equal to tangent of theta. So it looks almost identical to what we have to the left here. But this way is actually probably a little bit more challenging. Before we move on, I want to caution you of one thing, and that is, while you can split up the numerator like we did in this example here, of course ours was subtraction, but whether this is addition or subtraction, you can use this idea where you can split that numerator up. It is unfortunately not true, though, if we had a, say, sum or difference in the denominator. This is not equal to C over A plus C over B. And this is because we'd have to get a common denominator in order to add these two together. And if we did that, well, we'd end up with C times B plus C times A all over A times B, which is not equal to C over A plus B. So again, you can split up the numerator if there is addition or subtraction, but we cannot do this to the denominator.